All right, so we're going to start to talk about polar coordinates, which is just another way of expressing a point in the Cartesian plane. Well, maybe not the Cartesian plane, but the two-dimensional plane. Okay, so we defined two quantities here. Well, first of all, notice that we have the point xy and we have the point r theta, so they correspond to each other. So for any point xy, there is another way to express it in terms of an r and a theta. So r is the distance between 0, 0, and xy, as you see in the figure here. So for most cases, r is going to be positive. There are instances where we're going to want r to be negative, so we're going to have to be careful of that. And theta is the angle as you see here. So if I draw a line from 0, 0 to the point, theta is the angle that we have to traverse to get from the positive x-axis to that side. And this is not something we haven't seen before. It's the typical way we measure an angle theta. So with this in mind, let's just take a look at some relationships that we can get from this. And I'm going to draw a vertical here. And I'm going to say that this side is y and this side is x, because we have to go over x units and up y units to get to that point. So by setting up a few equations, let's see what we have here. So I'm going to say sine of theta is equal to y over r, which means that y is equal to r sine theta. That's a nice little relationship. Following the same idea, we get x equals r cosine theta, and just realize something. If I know the polar coordinates for a point, I can easily locate its x and y coordinates. Okay, so these are going to be used when we know the polar point and we want to go back to rectangular, so I'm going to say p to r. Now, other relationships we have, well, let's see. Pythagorean theorem looks like it comes into play here. I'm going to say x squared plus y squared is equal to r squared. And I'm also going to say r equals the square root of x squared plus y squared. Now that's assuming that we want r to be positive. And in most cases, I'd say 99% of the time we want r to be positive. There are times when we want r to be negative also. So just understand that those two are both valid relationships there. Now to get theta into the mix, I'm going to take the tangent of theta. And the thing to notice is the tangent of theta is y over x. So these guys are going to be used when we have the rectangular point and we want to go to polar. As we're finding out here, if I know the polar coordinates of a point, I know exactly how to get to the rectangular point. But if I have the rectangular point, getting to the polar coordinates is going to be a bit of work. So that's where we're at right there. So those relationships all right there. So if I wanted to tell you how much or which ones you need to memorize, I would say this one, this one, this one, this one, and this one. So in the next video, we're going to talk about plotting points in polar coordinates, and then you'll be able to see sort of how they correspond to the rectangular coordinates. So be sure to come back for more videos.